Okay, I'm going to talk to you a little bit about problem solving. And I would love to say that these ideas are original to me. But they're not. They come gleaned from other people, other chemical educators, people like the famous George Bodner at Purdue, from Dudley Herron, from Cliff Schrader, a wonderful high school teacher with a PhD. He taught high school his whole life. At the end, he was teaching some teacher training at colleges, but a wonderful person. Ken Spengler, a wonderful high school teacher. All these people, I put these ideas together that you're going to see today. It's not going to take long, but I go through this with my students. I want them to know how to solve problems, and I'm going to tell them the ideal way, or at least my way, that this may help you solve problems. So we're going to see each step on the camera. So let's take a look at the first quote by Dudley Herron. This is a good way to start out. Because energy is limited and learning is directed towards survival, we seek to learn with the least cognitive effort. Students will do anything to circumvent learning. All right? They just want to get through the day without failing and doing the minimal amount of work. Just to a certain extent like we do. We all want to do that. So keep that in mind. If you show them or model them how to solve problems, they may buy into it. So then the next part is, what is a problem? And many people have presented this idea. Problem is when there is a gap between where you are now and where you want to be, and you don't know how to cross that gap, you have a problem. Okay, there's the quote where it's from. By who said it. Problem solving. What do you do when you don't know what to do? That's it. That's much different than an exercise. Okay, many, but not all problems in text are routine exercises. You plug in, you come up with a number. That's an exercise. That is not a problem by the definition that we just saw. Novel problems in text are where you don't know what to do. That's a novel problem. Now, in your high school chemistry text, hopefully most of these are not novel problems to you. All right? They may be the first year. The first year teaching, there were a lot of novel problems to me. Going, whoa, I never thought of it that way. How did they get that answer? Especially when the answers in the back weren't the same as mine. Especially if the answers in the back were wrong. That happens on occasion. I love to assign those to students, though, and see who put that down. That was good. Novel problem. Most of the things are exercises for you after you've taught a few years. You can do them. And it's amazing, isn't it, sometimes how the kids become dumber after about 10 years? They can't do this stuff. Where at first it was, whoa, we got to learn this together. So there's a method for problem solving. So let's take a look at that method. The method for teaching problems. Read the problem. Read the problem again. Write down what you hope is relevant information. In other words, write down a given. Boy, that means you've read the problem and thought about it. Draw a picture, make a list, write an equation or a formula, or chemical equation or chemical formula. Do something. Try something. Trial and error are legit. Try something else. See where it gets you. Read the problem again. See if you've been reading it wrong to start with. Try something else. See where it gets you. Test the intermediate results to see if you're making progress. Read the problem again. Aha! You see it! Write down an answer, not necessarily the answer. Test your answer to see if it makes sense. Start over if you have to. Celebrate if you don't. Look, if you're doing a mold problem, you come up with 45,000 million grams, you've probably made a mistake. All right? You may have to start over. Now, problem solving is different than using an algorithm. Click. An algorithm is simply a rule that can be made more or less with the brain on autopilot. You're following some pre-described set of steps that you don't have to think about. They may work for some things in this class, but don't count on it for the test or real learning. You need to know what the heck you're doing in my class. And I talk to my college kids and I talk to my high school kids about that. Take time, read the chapter. Now, the ideal thing is to read the chapter before you get there. I said, if you really want to learn this stuff, read it before you come, so you'll actually know what I'm talking about. That may help. Listen in class and reflect upon what is being said. And do the homework in a timely fashion. This is the ideal situation. I know it doesn't always occur. Be able to tell a story in your own words about what's happening. If you can put it in your own words, that means you understand it. If you can explain the chemistry to somebody else, that means you understand it even better, and it'll help you to develop a deeper understanding. On some of my AP kids, some of the tests I would give, I would say, in the question, tell me a story about how ionization works. Tell me a story about the Debye-Huckel limiting law. And I'd maybe give them a real problem, a math problem, but then they'd have to tell me a story, which means 3 or 4 sentences explaining what you did, why you did it, and what it means. Because, and I've been alluding to this throughout these few talks I've been giving, this next quote, indirectly, but here it is, click. One of the 4 reliance principles in Buddhism is rely on the meaning, not just the words. Reflect on that. That's something very important to think about. You need to know the meaning of the words before you can solve the problems. Definitions are important, and understanding is important. I firmly believe that.